We're going to explain how to add inputs to jobs in a robot program. This is crucial for making your robot programs flexible and reusable. Instead of hard-coding values, inputs allow you to change parameters easily without modifying the core program. There are several ways to achieve this, depending on your specific robot controller and programming language. Let's explore some common methods. 1. Using variables. This is the most fundamental approach. Declare variables within your program and assign values to them before the job starts. You might have a variable for the number of parts to pick, the location of a pallet, or the speed of a conveyor. The robot program would then use these variables in its calculations and actions. For example, parts to pick equals 10, and then later in the program, a loop would iterate parts to pick times. This is simple and effective for static inputs known beforehand. 2. Input from a text file. For more complex scenarios, read input parameters from a text file. This file could contain a list of coordinates, part numbers, or other data. Your robot program would read this file at the start, parse the data, and assign values to your variables accordingly. This method adds flexibility. You can change the inputs by editing the text file without altering the main program. For example, the file could be structured like x100, y200, z300, which would be read by the program to set coordinate variables. 3. Using an HMI, human-machine interface. Many robot controllers offer HMI interfaces with input screens. These screens can be used to input parameters directly before the job starts. The user might enter data through text boxes, drop-down menus, or numerical sliders, with the values getting directly passed to the variables in your robot program. This is excellent for quick adjustments and operator interaction. 4. Database integration. For high-volume automated systems, integrating with a database is a powerful option. Your program could retrieve job parameters, like part specifications or production sequences, from a central database. The robot would fetch the required data for each job, making it highly scalable and adaptable to changing demands. This usually involves using specific database connection libraries within your robot program. 5. Passing arguments through a script or calling program. If your robot program is called by another program, like a supervisory control system, you can pass arguments as inputs. The calling program can set these arguments, potentially based on real-time production data or scheduling information. This method provides tight integration with other automation components. This approach can be useful for changing aspects of the job, such as a certain coordinates value or a specific parameter at runtime, without having to manually enter them through an HMI each time. These methods provide different levels of flexibility and complexity, and the best approach will depend on the specific application. Simple jobs might only need variable assignments, while more sophisticated systems will benefit from database or external script integration. Remember to always include robust error handling in your program to manage unexpected input situations.